Hello, welcome back. Previously, I thought of only have one clip for k-means algorithm, but then I realized that there should be one additional clip for the evaluation of the k-means result. Okay, so that's what I'm doing it now. Okay, evaluation. So in order to evaluate the result of k-means, we should look into the advantage or the good or the disadvantage or kind of bad or not so good of k-means first. So let's look at the good one. First, k-mean is quite easy to understand by the analyst. And also to understand and to implement it. So that leads to the second goodness, which is make it quite popular for all the data scientists or either statisticians. Okay. So let's look at what could be the not so good, not entirely bad, but a little bit less good in this case. First, the k-means, it's only support round shape of cluster. So that means if your data problem is irregular shape, in that case, k-means might not be the best choice. And also number two, often the algorithm calls for the number of specific k before you actually run it. But in reality, a lot of people, not even the end user, have no clue what the right k should be. So that means no clue of which k to use. Okay, so should k be 2, 3, or 5? Or how about 9? So you can see that it's quite confusing or no hint at all. And because of 2, the related one, it means if you need to run many times for different value of k, that means on the new k needs an entire run. I mean, like go through all the data points of the whole set. Okay, so that means it can be inefficient. Anytime you want to try a new k, you have to run the whole thing through the whole data set. So therefore, that's something to think about. Okay, but for addressing number 2, like which k to use, there are some evaluation that done previously by a lot of data scientists in the several years ago, or what we call statistician then or now data scientists. Any evaluation of cluster tend to rely on these two qualities. That is, first, we try to maximize the intervariance between clusters. Okay, that means the cluster each has to be far apart. But at the same time, number 2, we want to make sure that within cluster it is compact. That means we try to minimize the intravariance within each cluster. So with this set of quality in mind, one example of KPI for clustering can be used. It's called Dunn index, D-U-N-N, okay, named after Professor Dunn in statistics several years ago. So in that time, for example, he was giving that if, for example, in this example, we have 8 data points. Given 8 data points. But the point is, Professor Dunn was curious how to evaluate the goodness between the option 1 when we run k equal to 2. And the same 8 data point can be run using k-means and break it into 3 clusters. So which one is better? So during that time, Professor Dunn resort to these 2 qualities and put it into ratio. So let's look at the top number of the ratio. The top part is we try to find the smallest, the smallest distance between any pair of centroids. So that's keep in mind on the top part. And at the bottom part, we try to look for any pair of distance that's the biggest for any pair of data point in any cluster. So we kind of try to look for the pair of the champion pair which further apart. So keep this in mind. Then we go ahead and back into our previously data points before. So with this data point, let's look at the case of k equal to 2. So if these small blue x represent the centroid. So in this case, k equal to 2, so definitely the distance of 2 centroid has only one value. So in this case, the Dunn index, I use the suffix of 2 to represent k equal to 2. So the top part in this case is the minimum distance between any pair of centroid, but in this case we only have one pair to choose from. So if I call this distance A, so the top part is A. Now what is the go to the bottom? It's the maximum distance between any pair of data point in any cluster. So in this case, I would think that this distance pair, if I call this distance B, so that should together put together ratio into the Dunn index of k equal to 2. So now we can do similarly with k equal to 3. So let's find the centroid of each cluster. So the Dunn index for k equal to 3. So let's look at the top quality. Top quality, we look for minimum distance between any pair of centroid. So in this case, the minimum distance between any pair of centroid, I would call this F. So that is F. So what goes into the bottom is the maximum distance in any pair of members within any cluster. So I think this quality represent, if I call that distance G. So what are we looking for? The goal is we are looking for bigger Dunn index. The better cluster result. The bigger between these two. So in this case, you have to look for the maximum among them. So in this case, have to figure out whether is Dunn at 2 bigger than Dunn at 3 or not. So which one the bigger, that represent the better quality of the outcome clustering. Well, that's it for now. Thank you. Goodbye.